So I will be talking about principles of differentiation. Differentiation is the first part of calculus. What is differentiation? Change. So dx over dt. What is d? D can represent change. So what is x? X is a position. Imagine this little guy walking through that track, and t equals to time. Just imagine the clock moving. So the change in position over change in time equals to velocity. Velocity is your speed. Now if we take velocity and we differentiate that over time again, that equals to your acceleration.
These are the types of differentiation: first derivatives, second derivatives, and higher order derivatives. I'm going to talk about the first one, but I'll be using rocket as an example for this. Calculate how fast a rocket's position with respect to time, or should I say position versus time. So this is the example. 5t squared, you differentiate it, you're going to get 10d. Going on to second derivatives, is calculate how quickly the rocket's velocity changes during thrust. This is the formula, which is basically velocity versus time. So by using the first derivatives, you derive it again, you're going to get 10. Moving on to the last one, higher derivatives. Geom is used in advanced trajectory optimizations, and application is to ensure smooth transitions in trajectory and reducing stress. This too is going to be the formula that you're going to use for higher derivatives. The third variable formula is the same thing as the second variable, with an extra dimension.
Some differentiation. The first technique is simple differentiation, where y equals x power n, which equals n times x to the power n minus 1. Another technique is chain rule, where y equals to a function within a function, where the outside function's differentiation is multiplied by inside function's differentiation. Another technique is when two functions are multiplied each other, where the first function is multiplied by the second function time, plus by the second function multiplied by the first function time. Another technique is quotient rule, where a function is divided by a function, where the denominator is multiplied by the numerator's time minus by numerator times by denominator's time over denominator square.
Moreover, implicit differentiation is another technique, in which case we have the function z is equals to fy. Once we differentiate this particular function, we have to make sure that the denominator and the numerator are the same, in which case is dy. Additionally, for partial differentiation, we have this function, and then we have to make sure that dx should be on top of dz, in which case we have this function.
So now I'll be talking about principles of integration. What is integration? Integration is all about accumulation. Let's take this tank as an example. If differentiation tells you how fast water is flowing into a tank, integration is finding out how much water has flowed into the tank after a certain amount of time. So this is how integration works. You take acceleration multiplied by the change in time, that gives you v. And if you take the velocity multiplied by change in time, that gives you position.
Types of integrals. Before I explain the type of integrals, I should explain what's an integral. Integral is basically when integration is applied to a function, the results of the integral. Shown here, 5, integration being applied, it becomes 5t plus c is an integral. The first type of integrals is indefinite integrals, where there is no limits, and the other type of integrals is definite integrals, where there are limits shown here, where a and b is a variable. So example is here, 5 is the upper limit and 4 is the lower limit, and 5t plus c is a function. Techniques of integration, the first technique is simple integration, where it can be applied into multiple situations such as with one function or more than one function, where the area under the graph for one function is found using the integral, while for multiple functions is the area in between the two graphs.
Furthermore, partial fractions is another type of integration technique, in which case we would take the denominator and split them into two sections in order to find an answer singularly. As an example, the total power needed to escape through the atmosphere using a rocket is usually found by partial fractions. Additionally, another integration technique is use substitution, in which case we're going to find the value of u, differentiate it, substitute it, and integrate it to find the final answer. Finally, the final part of integration is by parts, is another technique which we will take this formula and in order to find this particular answer. Over here, we need both integration and differentiation in order to find our objective, which is the forces applied on the rocket. And over here are the 3 Newton's laws that apply on the rocket itself. And according to our frequency diagram, the thrust force acts against the weight and the air resistance. But over here, the thrust force should be more than the velocity of the rocket over time and the weight. And here it is the force due to gravity, which includes 4 variables. And one of these is the gravitational constant, which will need to be differentiated in order to find the value of factor 972. Over here, we have weight is equals to mg, and we would have to differentiate this in respect to dx in order to get mgx plus c, which is the work done against gravity. The thrust force over here is defined by the final time and the initial time, and in order to find the constant k, the max force over the max time squared, which is why we got kt squared times with dt. The air resistance over here otherwise is defined by half times with the density, times with the coefficient of drag, times with the cross-sectional area, and times with the velocity squared. And adding all of this, we would have to find the velocity of the rocket over time, which is defined by 1 over thrust force minus the weight minus the air resistance. To further simplify this entire equation, partial fractions are used, in which case it will be A over final velocity minus initial velocity plus with B over final velocity plus initial velocity, and we would have to integrate this in order to find the velocity of the rocket over time.